Alright, let's get started with today's problem. The first problem of the day is LeetCode number 5, longest palindromic substring. Given a string S, return the longest palindromic substring in S. Okay. So, let's get started with this. So, with a substring problem, we need to consider all elements between the boundaries that we have for our substring. They must, well, form a palindrome. In that case, I think a sliding window approach seems reasonable for now. It seems like a decent call. We'll see. Let's try to break down the problem into cases. Well, in terms of a palindrome, we could have an odd length where the middle is one character, or even length where middle is two characters. If it happens to be at the beginning, then all elements must be the same character. If the left side is at the beginning, then the elements must be the same character. And the reason for that is that as we expand the sliding window towards the right, then it makes sense that if the only way that we could preserve a palindrome, because there are no more characters on the left, is if the characters that are incoming from the right hand side are the same character. And I think that's most of the weird cases that we need to consider. Okay. Let me think. So how do you want to do this? We could start with a sliding window of size 1. Because a character will always be a palindrome, a single character will always be a palindrome. So our minimum is, in this case, 1, especially with the string length being 1. Then we can say if the left and right, first of all, if they exist and are the same, or if the right hand side exists, expand. So this way, when we expand, we will have a sliding window of size 2 or 3, depending on if we decide to go with the even route or the odd route. Then while the left and right side of the sliding window match, expand. Otherwise, slide to the next character after the right hand side. Well, we want to slide and shrink back to size 1. And of course, we want to keep track of the maximum and then return max. So the reason, okay, so let's go through this sort of pseudocode. Let's go through this one by one. We start by sliding window of size 1. because we know that with the size 1, that will be our minimum no matter what. We check if the palindrome would be of a size 3, or a core of an even or a core of odd. It just depends on whether or not the left and right exist and are the same, or if it's just the right hand side. Then we expand our palindrome, or rather our window, so long as our left and right sides exist and are the same. So after the initial sort of core part, then it really doesn't, there's no differentiation between the odd number and the even number palindromes. And if we end up hitting a point where they're not the same, then we know that that palindrome is essentially complete. And therefore we can slide and move on to the next character, which is the one after the right side. I guess the main problem, let me think. There may be a problem here where when it comes to this, if we had a string like A, B, A, we would count this as a palindrome first, then we'd shrink here, then we would expand, and expand again. But the problem is that we're kind of doing duplicate work here because of the fact that we measure this as a palindrome, and then we do this, and then we do this again and expand. But I'm not sure if there's any way around it because of the fact that we really don't have any information on the right hand side and whether or not it will match. Sure, we know that this substring is a palindrome, and we know that it's the longest palindrome that we've seen so far, but we have no information that this right hand side is also a palindrome, and also the same as the left hand side until we've iterated over it. So I don't think that's a huge concern. But otherwise, I think this solution should work. Well, how fast will this run? Well, let's assume that the sliding window expands to the maximum that it could be every single time. Let's see. Well, let's suppose that we had, and this is without optimizing for this case where they are all the same character. Well, we'll start with 1, then we'll start with here, and then we'll start with, so we'll go window size 1, because there's nothing on the left. Or we can expand to that, like that. But, okay, so we'll have window size 2, then we move over to here, and window size 3. Here we could do a window size 5. So basically we sort of do a like 1 plus 2 plus 3 plus so on and so forth plus n. Though we do skip a few numbers here and there, but ultimately I don't think those numbers in between matter too much. And in that case, I think it's safe to say that our solution will probably run in some flavor of O of n squared time, or some form of polynomial time, where n is the length of the string. I think that makes sense. And we will have O of 1 space because we're not really collecting any additional data besides, well, the length of the longest palindromic substring that we've seen so far. And I think that this is a pretty reasonable solution. I think O of n squared is fine. Looking at the constraints, I think 1000 squared, or the limit being 1000, I think seems to lean towards it being a slower solution. But who knows, maybe there's an even more optimized solution. But let's go ahead and start coding this up. So let's start with var longest string, or yeah, longest window is equal to 1. And we can say if s.length is equal to 1, return 1. So there's just no reason to continue at that point. And then we can say, because we want to, this is going to be a mutating value. This is going to be a mutating index. And in that case, we probably want to do a var left window is 0, right window is 0. And we can say while right window is less than s.length, we will say val core is equal to I'm not sure if we need to define this core. We'll see. We will say that if left window minus 1 is greater than 0 or equal to 0, and right window plus 1 is less than s length, and we can say var does core exist? Actually, the core will exist. It just depends on whether or not we need to shift it. So really, the only thing that really matters is actually this special case here. Or the only thing that we really need to check beforehand is the special even core case. So in that situation, so if both the left and the right are valid, and the s at left window is not equal to s at right window, and let me think. So let's let left window be our primary index. And in that case, if left window assuming that left window and right window will get sort of reset. So I think this part will be index actually. So if we have an index on the left and the right, and the left and the right are not equal, but s at index is equal to s index plus 1. And we can say var left window is index, var right window is also index. Then we can say right window is equal to index plus 1. So this will be the core is even size. So the middle is 2 numbers rather than 1 number. If both of the sides exist, but we have them as not equal, but the next value is equal, then we can say while left window minus 1 is greater than or equal to 0, and right window plus 1 is less than s length, if s at left window minus 1 is equal to s at right window plus 1, actually we could do while s get or null left window, oh no, but then it will we can stop for that, we can account for that. Okay, so while s get or null is not equal, or is equal to s get or null right window plus 1, and s get or null left window minus 1 is not null, and not this and s get or null right window plus 1 is equal to null. So the idea is that while both of them are equal to each other, but both of them are not null, right? Because if they're both null, then they've probably exceeded and we don't want to continue there. Then we can say left window. No, we want to expand until either of them are null. Which this will catch. So this will keep on growing until one of them is null or both of them are null. And we can say if right window minus left window plus 1 is greater than longest window is equal to right window minus left window plus 1. So this expand until one or both are null. The first case will also catch if one of them is null, because one of them will be non-null, and obviously a null can never be equal to a non-null. And then the second case is if will catch if both of them are null, because if that is the case, then this inside case will be true, and the outside, and therefore this negation will make it false, and therefore anything and false will be false. Then we return longest window, and of course we should also change our index to be equal to our right window plus 1 in order to skip the last value. So let's throw this through some tests on our own. So let's do BABAD. So at index 1, or index 0, or this while index should be less than s length, then left, I'll just abbreviate them as L and R, are equal to 0. Then not both of them are null, or not both of them are valid. Only the right hand side is valid. And since one of them is null, at left window minus 1, we just return 1. At I is equal to 1, left and right are equal to 1. The right and left windows are both valid. However, the right and left windows are well, sorry, the right and left windows are valid, but they are the same. So we will not expand our core by 1. However, we do run through this while loop, this s get or null. Left window minus 1 would be 0. Right window plus 1 would be 2. And they are the same. Both are B. And both of them are non-null. So false and false is false. And negation of false is true. So true and true. So we expand this. And then we continue. Well, in this case, we go one more again. Null, left window minus 1 is negative 1, which is null in this get or null. And this get or null returns A. Well, null and A are not the same, so therefore we skip to here. And, well, right minus left, so that's 2 minus 0 plus 1, that's 3, is greater than our initial longest window of 1. So we will set that there, and then we'll continue. And we continue by setting index to the right window plus 1, which would be A. And A, well, we had the left and right not as the same, but the right side is not the same as our initial index. So we just skip that. I wonder if we could probably simplify this statement as well. We could consider making this more Kotlin-esque, though I think we'll leave it like this for now. So that doesn't do much here. There is a left and right, but they're both null, so we'll just continue. Or they're not both null, they're different. And then here, well, s.length, our index plus 1 is not less than s.length, so we won't go through this. Left is null, right is null, left is non-null, it is A, so they're not the same. And this window is just size 1, which is nothing special. And here we increment to the next one, which is at s length. And after that, we just return our longest window. So this seems to work. Let's go ahead and run our code, and let's see if there are any issues that we need to deal with. I see. This needs to be a string, not a length. I see. In that case, I wonder if, or which one we need to actually return. I assume that there may be multiple longest palindromic substrings. At the very least, if there are if they're all unique characters, then any of the strings would be any of the substrings of size 1 would work, right? Would be valid. Well, in that case, if the size that we have accomplished is larger than the longest window.size, then we set it to s.substring from left window to right window. The problem is that we know that one of these, left window or right window, are null. Right. We know that one of those may be null, or perhaps both of them are null. So in that case, we might need to change it and this substring, and so this substring will coerce this left window to be between 0 and left window, and you will also coerce between right window and s.size. Because that's the maximum. So on the left window, we coerce it to be between the minimum of, or at max, let's see. At the minimum, it must be 0. At the maximum, it must be left window. And this is just to make sure that we aren't dealing with, this is just to make sure that we're not dealing with any crazy values. And then the right window, we coerce it to be at the maximum of the s.size. I hope that works. Though now I'm thinking of whether or not we would have a situation where the value is actually larger. The left window, the right minus left window plus 1 would be greater than longest window.size, but not because of anything like, basically because of the nulls. That might be the case, but first let's see if this actually compiles first. Unresolved reference size. This should be length. And I think this is coerce in. And this is right window plus 1 that we want. Because this is exclusive, right? For the substring. So we want at least the right-hand side to be plus 1. Cool. So it worked for the first string. Let's try the other string. Looks like it worked. Let's throw in a submit and let's see how we did. Oh, interesting. Let's see. Let's do this then. While right window is less than s length and s at right window is equal to s at index right window plus plus. So this just expands it so that we capture the entire string in front of us that has the same characters. First. Then we see if we want to expand it further. Though, do we even care about expanding it further at that point? I guess like in that case. That's a good question. This might not be necessary in that case. I'm gonna comment this out because this might not be needed since we have this case. Yeah, I think so actually. Let's try this again for the initial examples, because I think this actually overlaps and checks that. Plus 1. Plus 1. So that works there for the second case. Let's run it for this case. Let's run it for u, and let's just get rid of u. So just a little bit more succinct. Lots of while loops though. That seems to have worked. Let's throw in the submit again. A and A. Right, because we check here that's invalid, then A also invalid, N, this does A, and then this skips to N rather than staying at A. Maybe then we want to move the index to right window rather than right window plus 1. But is there a possibility that, but that throws in a TLE. If right window is equal to index, then we want right window plus 1, or we can just do index plus 1, else right window. But now I'm thinking, is there any other case where this would not work? And what I mean by that is it only the right window that we need to worry about that could actually start the longest palindromic substring? Or should we just increment index one by one in that case? That's a really good question, honestly. Because it'll work for this one, because the longest palindromic substring starts right at A. Or at least it should. Seems to have worked. But the problem really comes down to whether or not this needs to happen at every single character or not. Because what if a character in the middle also happens to have it? Yeah. Okay. In that case, I'm going to sort of sabotage my speed right now. And just first, let's run through the gamut of tests and just throw in the palindrome check at every single index. This is probably slower, but now we sort of guarantee that we will catch the longest substring because we are checking every single index for the longest palindrome, essentially. The problem really comes down to cases like this where the strings are just longer, because then we start checking pretty much until the end for each one, which is bad, which is pretty bad. But we'll see if this is fast enough to take us through, or if there's something else that we can consider. Okay, looks like it is actually fast enough. Awesome. But yeah, so the idea is just that we need to check every single index. There's no guarantee that our longest palindromic substring exists only at sort of contiguous intervals. So we need to check every single character. Awesome. So looks like we did a decent job in terms of runtime and memory. Not the cleanest solution, especially with all these while loops and the coercion and all of that, but it works. And yeah, in any case, I hope you learned something, and I will see you for the next problem.